All right. Welcome back to the Math Concepts. Today we're looking at 2015 Add Math question 3. So here it is. It reads, the equation of a circle is given by x squared plus y squared. I'm reading here. X squared plus y squared minus 12x minus 22 plus 52 equal 0. Determine the coordinates of the center. Now, to find the center of the circle, what we want to do is to make sure that we understand the format. To find the center, we're going to be writing it in this format. A minus x squared plus y minus b squared, and that is equal to r squared. If we write it in this format, then we will be able to pick up the center using these values there that we got. And then we'll get the radius by taking the square root of any number that we get over there. So basically, let us set up this now in that format. So I'm just going to shift my screen a little bit to the left and then work this out. So here goes. We're talking about x squared plus y squared minus 12x minus 22y plus 152, and this is equal to 0. Basically, what I'm going to do is to get two perfect squares, one with x's and one with y. So I'm going to isolate my ideas. And what I mean is x squared minus 12x. I'm going to leave a space for that. I'm going to organize that. Plus, I'm going to organize the y's over here. Y squared minus 22y. I'm going to leave a space here as well. Right? And then my 152 will be a negative 152 on the other side. So basically, I subtract 152 from both sides. So let us go through. I'm going to make a perfect square here. So I'm going to find a half of this number here, square it and put it there. A half of this number here, square it and put it there. So let us go. A half of 12 is negative 6. So when I square, so half of 12, half of negative 12, negative 6. So I'll have negative 6 square going there. If I add negative 6 square there, I have to add negative 6 square on the other side as well. So I'm going to be adding that. Negative 6 square. Here, this part, negative 11. Negative 22 divided by 2 is negative 11. And then I'm going to square it. And then I have to add it to this side as well. So let's get the numbers. Here, I'll definitely have x squared minus 12x plus 36. Also, I have y squared minus 22y plus 121. And this is equal to negative 152 plus 36 plus 121. So what we have to do is to factorize these, but the factors for these is simply those numbers that we actually use to create the square there. So here it is x minus 6 squared. So if you expand that, you'll get back this. Here we'll have y minus 11 squared. And when we add these numbers at this side, we get 5. Now, so when we look at this idea here, we're looking at all of this square. So what is the question? So the question says the coordinates of the center. The coordinate of the center would be the opposite of these numbers here. So the coordinate will be positive 6, positive 11, and that is the center. Positive 6, positive 11, that is my center right there. Find the radius. The radius is going to be the square root of any number that we have here. Because this is the radius square, so the radius is the root of 5. That's my radius, the root of 5. Because from the general form is the radius square would be out there. So it's going to be the square root of 5. Determine the equation of the normal to the circle at the point 4, 10. So the equation to the normal, right? Remember though, if we should create a quick idea of this, we should create a quick idea from this. This is basically what we have. There is a circle that we have, yeah? And it has it has a radius. And there is some tangent line, which is what we'll call the normal. There's some tangent line to it right there. So what happened is that the tangent is this. The normal is at right angle to the tangent. So the normal is the radius. Let me take this off. So the normal is the radius. So the normal is the radius. Remember that the center is 6, 11. But the point that it passes through, we were told it is 4, 10. So then basically what we're doing, we're observing this idea here. That line right there. So all we have to do is to find the gradient and use the gradient at any one of these points to create the equation of it, the normal. Now let's find the gradient. So what we're going to do, we could label x1, y1, x2, y2. The gradient of the normal is y2 minus y1 over x2 minus x1. We're definitely looking at 10 minus 11 over 4 minus 6. I'm getting -1 over -2, which gives me +1/2. So we have a +1/2 here for our gradient. Remember though, I could use any one of these points. I'm going to use the point 10 and the gradient, which is 1/2, to substitute in y equal to this idea to find c. So then let's go about finding c. Y, this is a x and that's a y. So 10 is equal to 1/2 times 4 plus c. 10 is equal to, let's cancel, 2 into the 1, 2 into the 4, 2, 2 plus c. Let's subtract 2 from both sides. 8 is equal to c. Now, if I know that I have the gradient to be 1/2 and the y-intercept to be 8, then the equation of the normal is this. So the equation of the normal is y equal to 1/2 x plus 8. There it is. That's the equation of the normal right there. Let's see if we could look at the next question. The next question is a vector question, and it reads, it says the position vectors of the points P, position vectors of 2 points A and B relative to the origin are as such. We're looking at them right there. What they're saying to us is they want us to find the unit vector AB. For us to find a unit vector, what we need to do is to first find the vector AB. So the unit vector AB will be such that we will actually have finding what we want to do is to find the vector AB, and then from that we're going to set up a quick system. So let's go for the vector AB first, right? So let's go for AB. So in going for AB, we will be moving from A to O, and then we're going to go from O to B. So we're talking about AB. A to O, Then we move from O to B. So what do we have here? A to O is the inverse of OA. So it's going to be negative 3I plus 2J. So we're going in the opposite direction of OA. So we change the signs on the component. And OB will be as is, 5I minus 7J. Let's put it together. Negative 3I and positive 5I will give me positive 2I. Positive 2J and minus 7J will give me negative 5J. So here it is that we'll have AB. Now, since I have the vector AB, then what I need to do to set up the unit vector is to find the magnitude of AB. Let's go for the magnitude of AB. The magnitude of AB is to use the Pythagoras theorem, where we're going to be having 2 squared plus negative 5 squared. 2 squared is 4, negative 5 squared is 25. Bottom line, it's the root of 29 units. So that is the size of the vector AB. Now that we know the size of the vector AB, we can write the unit vector AB. We're simply going to have the components being divided by the size of the vector. What by that I mean this. 2 over the root of 29I minus 5 over the root of 29J. And here we'll have it, the unit vector AB. So basically, it's finding the components or finding the vector AB and then divide each component by the magnitude of the vector AB. And we would have our unit vector right there. The next question, though, says the acute angle. We want to determine the acute angle AOB in degrees to 1 decimal place. Now, let's look at AOB. So we'll definitely let's look at, let me write OA is 3I minus 2J and OB is 5I minus 7J. So what we want to find is the angle between these two vectors. Now, if we want to find the angle between them, right, it is said that A dot product B is equal to the magnitude of OA times the magnitude of OB times the cosine of the angle between them. And we're going to be using this idea to help us to solve the problem. Now, let's go about finding the dot product here. The dot product is to take the component. So let us look at the dot product. A dot product B or OA dot product B is take the components of the A, which is 3 times the 5, and we're going to be adding that to the dot product of the Y's, which is the negative 2 times the negative 7. I am looking at 15 plus 14, and the dot product is 29. So I know what the dot product is. The dot product is 29. Let's go about finding the magnitude of each because we'll need it for the formula. The magnitude of OA is equal to, using the Pythagoras theorem, 3 squared plus negative 2 squared. 9 plus 4 will give us the root of 13. So here it is, we have found that the magnitude of OA the magnitude of OB is equal to 5 squared plus negative 7 squared. Taking the square root, 25 plus 49. And I'm getting the root of 74. No, so we're going to put this together. So based on the formula, the dot product is equal to the size of OA times the size of OB, and that multiplied by the cosine of the angle between them. So this is 29, we're substituting, is equal to the root of 13 times the root of 74 times the cosine of the angle. Now, so what we're looking at here, we're going to divide both sides by the root of 13 times the root of 74. So basically, that's what we have right there. So we could set this up and say, listen, the cosine inverse of 29 over root 13 times root 74, and this is going to give us the angle between them. So at this moment, when we plug this in, we're getting 20.77. But the question asks for 1 dp, so the answer is 20.8 degrees for 1 dp, right? So there it is. Look out for the next question coming. Thank you for watching Daily Maths Concepts. All right, please like, share this video, drop a comment, and subscribe if you have not done so. Thank you. Bye-bye.